go ahead and finish up this multiple choice stuff with number 9 through 12, or 9 through 13, I think. Okay, so for number 9, it's pretty straightforward that you are interested in just doing a one-tailed t-test. It is wanting to know if it had decreased. It is just one mean. And then because it's one means, and you only have the standard deviation for the sample, you have to do t-test. You cannot do z. Z is mostly for proportion problems. You cannot do a t-test if you only have the standard deviation of the sample, which 10 applies to that. So let's look at 10. Which is the following reason that you would have to do a t-test? The reason is because the standard deviation that you have is coming from the sample. You only have the standard deviation from just that little bitty sample you took. So because you only have this standard deviation from the little bitty sample that you took, you have more variability, and t-distributions are more varied. So another way of saying that you only have the standard deviation of the sample is saying that the standard deviation of the entire population, the whole everything, is unknown. If I had the standard deviation for the whole everything, then I could use a z distribution, but rarely do you ever have that whole population standard deviation. All right, and for number 11, I just kind of started writing out the data. And what happens is when they tell us this standard deviation is just for the sample. So since it is just a sample standard deviation, you cannot use z-scores. All right? Now, since the size of the sample is 16, that makes the degrees of freedom 15. Okay, so that is why then E is wrong. And then since it wants to know if this has increased, we want to do the upper tail. So we want T greater than 2 with 15 degrees of freedom. All right, now what I want you to think of when you think about number 12 is, first of all, let's pretend that you are in the top 5% of your class. Okay? And so in order to get into a particular university, you need to be in the top 5%. Well, so you're in the top 5%. What happens if you have a university and they say, oh, you just need to be in the top 10%? Well, if you are in the top 5%, then you are in the top 10% automatically. But are you in the top 1%? And that is not necessarily. Okay, so think about that when you think about this problem. If you reject at the 5% level, then you're in that upper 5%. So you would definitely reject at the 5% level. You would also reject at the 10% level, but not necessarily at the 1% level. Okay. Oh, well, in this case, actually, it says that they reject at the 10%. Are you able to reject at the 5%? And again, same thing, not necessarily, because just because you're in the top 10% doesn't mean you're in the top 5%. All right? Okay, and number 13 ends up talking about the cancer rate being 23%, and they're talking about this being the claim, and then here is your sample results. And so what we're doing is doing a one proportion z-test. Proportions are always z-test. Here is the claim of 0.23. The x value is 15 out of 84. We want to see if it is decreased. And so when you go and run a 1 proportion z-test in your calculator, you get this p-value, which would cause you to fail to reject. Okay, so since you fail to reject, the p-value, see the p-value is above 0.10. All right, let's see, and that's all of them. Okay, so the next video has the rest of the review.